Okay, moving on to 1C. 1C, we are comparing between sodium nitrate and potassium nitrate. Now, do recognize that both of them are ionic salts. You have your K plus and NO3 minus. You have your Na plus and NO3 minus. So they are your ionic compounds. And so over here, we are comparing melting points of ionic compounds. What is the immediate concept that we need to compare? So we have ionic compounds, we typically compare its lattice energy. So recall lattice energy has to do with measuring the strength of ionic bonds. So lattice energy, as a quick recap, Q plus and Q minus refers to the charge of the cations and anions. R plus and R minus represents the radius of the cations and anions. So in this case, the anions is the same, so the charge and the radius for anions is the same. NO3 minus is the same for both. What's different for Na plus and K plus is not in terms of charge, it's more of the radius. Your potassium is larger than your sodium. Okay, Na plus. So recall, again, important thing to take note, be very specific in your response. We are looking at ions. So it's ions, alright? So the plus charge needs to be clearly indicated in your response. Okay? And once we work out this, we make reference to the lattice energy because, as we mentioned, lattice energy can be used as a measure of how strong the ionic bond is. So the magnitude of lattice energy based on the formula, if K plus has a larger K plus is larger than Na plus, it's going to affect the denominator. With a larger denominator, lattice energy magnitude will be smaller. So sodium nitrate will have a larger magnitude of lattice energy compared to potassium nitrate. And this corresponding means that the ionic bonds of sodium nitrate will be stronger than potassium nitrate, and therefore requiring more energy to overcome the ionic bonds between opposite charged ions. So you can see, even though we talk about ionic bonds here, I have deliberately included between the species. Alright, so remember, always bonding, you have to specify the species involved. And this sodium nitrate will require more energy than potassium nitrate, and therefore melting point of sodium nitrate is higher than that of potassium nitrate. Alright, so this is quite a standard recall questions when we compare ionic compounds. Alright, so just take note, the common mistakes that many of you use was this term that you guys use. Many of you use this word charge density. Now, charge density is not applicable here. Although charge density means Q plus over R plus, which looks somewhat similar to over here, it's not applicable because charge density, we are looking at distortion of anion electron cloud. So this typically is more for covalent character in ionic bonds. So you see us using this word charge density only in when we want to explain for covalent character in ionic bonds, which is not applicable in this context. Right? We're just strictly comparing between two ionic compounds. Okay, if not, we move on to part 2. Part 2, in this case, compare part 2 to part 1. Part 1, we make the assumption or make the conclusion that sodium nitrate has a higher melting point than potassium nitrate, but the question says, in actual fact, sodium nitrate has a slightly lower melting point than potassium nitrate, so just a reason why. Now, when you see that lattice energy cannot be used to account for the melting point of ionic compounds, the only possible thing that can come to your mind immediately will be due to ionic bonds with partial covalent character. So sodium nitrate has some ionic bonds with partial covalent character compared to sodium nitrate, and therefore it requires less energy to overcome. Now this is for one mark response. So I want to go through this concept fully so that you can appreciate this concept better. So recall, covalent character of ionic bonds will increase when the cation is small and highly charged. In other words, remember we just talked about the term charge density. So charge density, as I said, it's about increasing extent of covalent character. And the anion is large and polarizable. In this case, nitrate is quite large. Alright, nitrate is quite large. Alright, so it's polarizable. So to look at the concepts, sodium does have a smaller cationic radius than potassium. As a result, based on charge density, Q plus over R plus, sodium does have slightly higher charge density than potassium, and therefore can polarize the anion electron cloud more. Alright, and this results in some covalent character in ionic bonds, and therefore typically what we observe is that when we have ionic bonds with partial covalent character, it requires less amount of energy to overcome. Alright, so with that we concluded question 1.